Now we're going to learn how to multiply two matrices. First, we're going to start by multiplying a row matrix and a column matrix in that order. And we're going to multiply a 1 by n row matrix and an n by 1 column matrix. The name of my column matrix here should be B. Notice that we have the same number of entries in the row matrix as we do in the column matrix. So what we do is we multiply the first entry in the row times the first entry in the column. Then we go to the second entry in the row, second entry in the column. We keep going that way all the way until we get to the very last entry in the row, multiply it by the last entry in the column. If you do not have the same number of elements in the row as you do in the column, they won't match up. That multiplication will not be possible. Let's do an example. Okay, let's suppose that we have, here's a row matrix. We're going to multiply it by a column matrix. Okay, what we're going to get is, we're going to do 1 times negative 4 minus 2 times 0. Okay, where did the 1 times negative 4 come from? Right here. Where did the negative 2 times 0 come from? Right here. And now we keep going. We're going to do 3 times 2. We're going to add these. And then we're going to do negative 5 times negative 4. We're going to add all these up. What we're really going to get here is a 1 by 1 matrix, and we can really think of it as being similar to a number. We're just going to have one entry in it. So we have negative 4 plus 6 plus 20, which is 22. Let's do another one. Okay, here we take the first entry in the row, that's 21, times the first entry in the column. Second entry in the row, negative 32. Second entry in the column. Third entry in the row is 19. Third entry in the column is 13. We're going to add all those up. When you do that, you should end up with negative 258. What happens on this next one? Well, if you start doing it, you're going to want to do the 3 times the 2, then the negative 2 times the 4, and then you run into a problem because you realize these are not going to match up right. I'm not going to have anything left to multiply that 3, and that's because these are not corresponding sizes. We have a different number of elements in the row as we do in the column. Here we have a 1 by 4, and here we have a 3 by 1. This multiplication is not possible. We cannot multiply this row by this column. So this is how we multiply a row matrix times a column matrix in that order. If you switch the order of your row and your column, you get something different, which we will eventually do an example of. Okay, so we're going to expand this to let us multiply matrices that are not rows and columns. Here's the idea. If A is an m by p matrix and B is p by n, then we can multiply them, and the result is an m by n matrix, which we can call AB. To get the entries, we're going to take the element in the ith row, jth column, and that's going to put us in the ith. The way we're going to get that is to take the ith row of A and the jth column of B. That probably didn't mean anything to you, but wait till we do the example and hopefully you'll be able to see how this is done. If the number of columns in A is not the same as the number of rows in B, the product is not defined. We cannot multiply those matrices. Okay, let's do our example. First of all, what we're going to look for here is, before we even start to multiply them, let's check the sizes. What's the size of A? 2 by 3. What is the size of B? 3 by 2. And if we're going to multiply them in A, B order, which we are, in other words, here we want to find A, B. So we're going to multiply them in the order that they're written here. What we want to look for is the fact that these two middle numbers, you want these to match if it's possible for them to be multiplied. Okay. If they can be multiplied, then we're just going to think of, I won't really say cancel off, I guess I just did say it, but if we think of these matching two numbers on the inside, if we were to cross those off, then our result would be a 2 by 2. In other words, here we have a 2 by 3, 3 by 2. Our result will be a 2 by 2. So I'm going to set myself up a matrix that's 2 by 2. We're going to go ahead and just put ourselves 4 slots so that we can fill them in. And we're going to fill these in one by one. To get the row 1, column 1 in our result, what we're going to do is we're going to take row 1 here, and we're going to multiply it by column 1 here, just the way that we did before. So we're going to do 2 times 1 plus 1 times 4 plus 3 times 1. That's going to give me 9. So I'm going to put the 9 right here because that is the row 1, column 1 position. Okay. Now, and I'm doing these separately so that you'll be able to see more easily what we do. Once you know how to do it, you would do this all in one step and wouldn't write this out 4 times the way I'm doing here. Okay, so here are my 4 slots. I already have a 9 in this one. And so now what we want to do is let's figure out what is in row 1, column 2. So what I do is I find row 1 in this first matrix, I find column 2 in the second, and I multiply those together the same way that we multiplied a row times a column in the previous example. So here I do 2 times 0. That's 2 times 0. And then we're going to do 1 times negative 2. And then we're going to do that 3 times the 1 right here. So we simplify that and we end up with negative 2 plus 3 is 1. And so I'm going to stick that 1 in the row 1, column 2 slot right here. Now we're going to move on to the next one. So I put myself, here's my 2 by 2 matrix with my 4 slots. I've already found the 9, I've already found the 1. What do we need next? Now we need to move on to row 2. So row 2, column 1. Let's do that next. Okay, so I circle row 2 here, and I circle column 1 here, and I multiply these two together. So that's going to give me 0 times 1 minus 2 times 4 minus 1 times 1. So negative negative 8. Sorry, couldn't add for a minute there. Negative 8 minus 1 gives me negative 9, which belongs right here. And that's my row 2, column 1. Now we're going to move on, and we have to get that last entry. So I found the 9, the 1, the negative 9. So now we need this last spot, which is row 2 and column 2. So I find row 2 here, then I find column 2, and so that gives me 0 times 0 minus 2 times negative 2 minus 1 times 1 which gives me 4 minus 1, which is 3. And that goes in that last slot. And so here is our answer. So that's step by step the general idea of how we multiply two matrices after we check to make sure that they can indeed be multiplied. Let's do another example. Okay, first of all, let's check to see what size they are. Here we have a 2 by 2 and we have a 2 by 2. What you're looking for is you are looking to see if these middle two match, and ours do. If they do not match, you can't multiplying. If they do match, just think of ignoring them and having those outside two numbers give us our result, which will be 2 by 2. And that tells us how big to make our matrix here that we're going to try to fill in. So first we do row 1, column 1. And so just think of taking this row times this column. That's going to give me 1 times 3 plus 2 times negative 1, which is 1, which goes here. Okay, now we want to do row 1, column 2. So we think of row 1, column 2. This is going to give me 1 times 2 plus 2 times 4. So 10. And that's going to go here. And so now let's do row 2, column 1. So we circle row 2 in my first, and then column 1. So this gives me 2 times 3 plus 1 times minus 1, 6 minus 1, which is 5. And then row 2, column 2. Row 2, column 2, 2 times 2 plus 1 times 4, which is 8. And so there's my result. Let's do another one. Remember how I mentioned that it was important when we did previously? When we first started this section, we learned how to multiply a row on the left times a column on the right. I pointed out that you will get a different answer if you do them in the other order and you put the column matrix first. And that's what we're going to see here. First, let's check our sizes. Remember, the number of rows always comes first, then the number of columns. Here we've got a 3 by 1. Here we have a 1 by 3. So can we multiply them? Yes. These two in the middle match. And so if I ignore those, after noting that they match, what should I get? 3 by 3. So I need to leave myself room for 3 rows and 3 columns. Okay, so first we do row 1, column 1. What are we going to do here? We're going to do row 1 of this first matrix times column 1. So what is that? 1 times 4, which is 4. So that goes in row 1, column 1 here. Okay, and now if we do row 1, column 2, what do we get? Row 1, you just have to get used to the idea of the row only having one entry and the column only have one entry. So we get 1 times 5, which is 5. Similarly, what are we going to get when we do row 1, column 3? We're going to get 1 times 6, which is 6. Okay, let's do row 2, column 1. Here's row 2, here's column 1. So we get 2 times 4, which is 8. And then for row 2, column 2, what do we get? Here's row 2, here's column 2. We get 2 times 5, which is 10. And then for row 3, column 3, we get, here's row 3, here's column 3. Which is 18, and actually I meant to do row 2, column 3 next, but that's okay. This is row 3, column 3, so where will that go? Right here. Now let's do row 2, column 3. So where is row 2? Right here. Where's column 3? Right there. 2 times 6, so 12. Okay. And now when you go back and do the others, you'll see that those come from row 3, so that'll be this third row, that'll be the 3. Column 1, I'll put me the 4, so that'll be 12. Then row 3, column 2 will be 3 times 5, which is 15. And so there is our final 3 by 3 matrix. So it's very important to keep in mind the order. We just discovered that matrix multiplication is not commutative. If you put things in a different order, at least with a row and a column, you get a completely different size matrix when you do it. Okay, let's try this one. First we check the size. Here we have a 3 by 2. Here we have a 2 by 3. We check to see if those middle ones match. They do. That means we can do it. And so if we ignore those, then what is our size of our result? 3 by 3, looking at those two outside numbers. I suggest you pause the video, try this on your own, and see if we match up. Row 1, column 1. Here's row 1, column 1. So 17. Let's do it in a different order. Let's do row 2, column 1. So here's row 2, here's column 1. So that'll be 4 times 1 plus 2 times 6, which is 4 plus 12, which is 16. So since we did row 2, column 1, it's going to go into row 2, column 1 over here. So you can do these in whichever order you like, as long as you put them in the right places based on the column and row and column that you used to come up with it. If I do row 3, column 1, here's row 3, here's column 1. So we're going to get negative 2 times 1 plus 5 times 6, which is going to be 28. So that goes here. And then for the next batch, you're going to need to do the different rows with the second column. So when we do column 2, here we go. So if we do the first row with column 2, we're going to get negative 1 times 2, which is 2. Negative 1 times 2, that gives me negative 2, plus 3 times 1, so that gives me negative 2 plus 3, which is 1. Keep going. You should get a 10 here, a 1 here. Let's just go ahead. I'll write out the third row. Third column. If I do row 1, column 3. Here's row 1, here's column 3. So we do -1 times 3 plus 3 times -2. -3 minus 6 gives me -9. Now let's do row 2, column 3. Here's row 2, here's column 3. So we get 4 times 3 plus 2 times -2. 12 minus 4 is 8. We're almost there. And then let's last do row 3, column 3. Here's row 3, here's column 3. So -2 times 3 plus 5 times -2. -10 minus 6 is -16. So here is our result of our multiplication. Let's do another one. First, before we do anything, we need to figure out what size our resulting matrix will be. What's the size here? 2 by 3. What's the size of our second matrix? 2 by 3. Ooh, look at the middle ones. They don't match. What does that tell me? I cannot multiply them. And so this is not possible. I cannot multiply these two matrices. Let's do another one. Again, here I suggest you pause the video and try to do it on your own, and then see if you get the same thing that I get. Here's a 2 by 2, 2 by 2. So our result will be, since these two match, our result will be a 2 by 2 going by those two outside numbers. So if we do row 1, column 1, (1 times 2 plus 2 times -1, which is 0. So we're going to put a 0 in here. Now let's try row 1, column 2. Here's row 1, here's column 2. 1 times 6 plus 2 times -3. That gives me 6 minus 6, which is 0. So I got a 0 again. Let's move to row 2. Row 2, column 1. Here's row 2, here's column 1. 3 times 2 plus 6 times -1. 6 minus 6 gives me 0. Lots of zeros. Let's see what the last one turns out to be. Row 2, column 2. Here's row 2, here's column 2. 3 times 6 plus 6 times -3. So we get 18 minus 18, which is 0. So we got the 0 matrix, even though neither of the matrices that we started with were zeros. Let's look at another example. And actually, if you compare these two, I should have put them on the same page. Here we have, let me just write it out before. In our previous example, we discovered that if we did 1, 3, 2, 6 like this times 2, -1, 6, -3. When we did this, we got 0, 0, 0, 0, the 2 by 2 0 matrix. I just want you to notice that so that when you get this one, you can compare your answer of this with the one that we got when we did it in the opposite order. So again, try this one on your own. Row 1, column 1 is going to give me 2 times 1 plus 6 times 3, which is 18 plus 2, which is 20. Row 1, column 2 is going to give me 2 times 2 plus 6 times 6, which is 36 plus 4, which is 40. Row 2, column 1 will give me negative 1 times 1 minus 3 times 3, which is minus 10. Row 2, column 2. Negative 1 times 2 minus 3 times 6 gives me negative 20. Okay, and so here's our answer, and that is definitely not the zero matrix that we got before. So that tells me that matrix multiplication is not commutative in general. Commutative, remember, when an operation is commutative, that means you could change the order. In other words, AB is not equal to BA in general. You could have a few occasional pairs of matrices A and B in which you can change the order. We call those commutative matrices. But as a general rule, when you multiply two matrices, you do not get the same thing necessarily if you switch the order. Okay, another thing we should notice from not so much this example, but the previous one, the zero property does not hold. What do we mean by the zero property? In real numbers, if we multiply two numbers A and B together, then we know that A is 0, or else B is 0, or possibly both. This is the property that you use when you use the factoring method to solve quadratic equations, when you factor it and then see each of your factors equal to 0. We can't do that with matrices because this property does not hold. In this previous example, notice right here, we have these two matrices. We multiplied them together. We got the zero matrix, even though neither of the original matrices was 0. So it's an important observation to make.